So I made this 3D printed this box a while back. I designed it to go onto the battery, put a couple of terminals in the bottom. I never finished it. The idea was to put a voltage regulator in there. It's got a light on it and USB socket. And yeah, just a couple of switches. So the idea was just to have a 12 volt output that I could run some. The idea was to run under a gazebo when camping, so I could use it quickly for lighting an area by itself, or use a USB socket and run like those LED light strips off it. Considering my 3D printer is not working at the moment and I'm not doing anything else with this at the moment, I am going to throw this aside and just use this base. So I've already drilled a hole in it, countersunk it a bit. So the idea is two spade connectors that are recessed in there. That all clips on to the battery like that. Yeah, it's a bit obnoxious, bright green, but at the end of the day, it works. Clips on nice and firm. So good thing is, I have this on file anyway, so if I want to continue the other project, I'll just print another one. Yeah, so the idea is now I'll set up, I want to hook this up on here. So what I've done is I've got some PVC foam board. This stuff's, actually I like this, it's pretty good stuff. The idea will be to set this up, hopefully something like this. So then the soldering iron holder sits up on there, that all sits up on the battery, and then it's just one piece. The battery itself, this is my smallest battery, even the bigger battery will even make a even firmer base again. So that's the plan. I'm only using hot glue so I can pull it all apart and redo it. Certainly love to put this in a case or some type of enclosure. If I do, I'm going to have to pull this connector off just because where the screen is and the buttons are and everything. That's not a big deal, just unsolder it and run it on some leads. Probably not a big deal at all. So yeah, it'd be nice to 3D print a case for this, but while my 3D printer's still not repaired, I'll just play with this one. Play with this base I've got here. So I reckon first thing I'll do is glue it up. Why not? Let's get stuck into gluing. It's half the fun. Messy like always. Gotta love hot glue. That's very hot glue. Hold it down for a minute. Yep, that's quite hot. That hurt. At least I know it's hot. Make sure that's the same way, the same angle. Now, I don't even know how well this hot glue sticks to this PVC foam board. I've seen a lot of people using it for modelling and all sorts of other stuff. I picked it up recently as a non-conductive base for a project that I had that had a lot of electronics sitting on it. So obviously wood, even with high humidity, ends up becoming conductive. So there you go, a couple of little angle pieces. They're not quite the same, but anyway, in fact, no, that's all right. They line up square even though they're not the same. Even though those angles are different, at least these angles are the same. It's only a temporary prototype anyway, just because I just don't want this circuit board hanging around and getting caught on something and shorting something out or destroying it. So let's get stuck straight into it, and just thinking whether, yep, I will. Just literally, I'll just hot glue it on there. It's only temporary anyway, so it'll come off again. With a bit of difficulty, but it will come off again. Decent blob at the bottom, so it sits in it. Blob at the bottom, and let's sit it on. hold it there for a few seconds. And it's a bit of fun, too much running down the front. And once again, surprise, surprise, that's quite hot. Alright, this is quite rough. Other reason for hot glue is obviously its rapid cooling rate makes it set real quick, and I want to pull it apart anyway. So, still a bit tacky. So that just holds the board down, and the idea of that is just holds it together. Nothing crazy, nothing special, just want to be able to solidly press the buttons, which you can, switch on and off, plug the iron into it, and I'll be happy. So next, I'll wire it up. Now, I won't wire it up with that hooked up because that battery's always live, so it's probably not the smart idea. Tin these two. I'll solder them up to the board, and then we'll go from there. Now, a lot of people soldering will, so they put the tip on the tip on wire heated up first, and then flow it on, which is good because then your flux gets in as well. But I like just putting just a little bit on. I find that just gives it a better contact and it heats up faster. Otherwise, it's kind of like a dry joint where you can sit there quite a while and actually not get any decent heat into it. So just that little bit of starter solder just makes it so much easier, and just a little bit of heating from underneath as well, just to make sure it's soaked through properly. So next thing I want to do is double check the polarity. So the polarity, obviously, positive is on the center pin like last time. As you can tell there, it's also on the board. So I'm thinking of just running straight to the board. If I'm going to do that, so I'll run positive first, negative second. Let's just double check with the multimeter that where those pins are at. So both of those are negatives, and that one up there is the positive. Always handy to check. Alright, let's toss a bit more solder in these because they're lacking a bit. That's better. Nice little mound to flow onto. Nice. I'll grab a bit more for later. So what I'm thinking, because I don't know the wire lengths, I'm going to solder these on first, flow that on. Cool. And then at least I can get my lengths correct after that. Let's do the same with here. I always find just that little bit of solder on the tip does make a big difference to getting that initial heat into the connection, especially larger connections like this. And that's all melted nicely. Cool. So positive on the rear, negative there, and that way I'm just not mucking around with this plug. So in the last video I set up this plug, handy for testing. I'll keep it, use it for testing other things. So positive is quite close, negative's further away. So let's grab that. We'll just do one at a time just in case. End up with a crossover or something like that. Nothing worse than cutting it just that little bit shorter than you should, and then having to redo it. And see how just that bit of solder just contacts the strands better, and helps heat up the surface before they get going and applying the rest of the solder. Just let it heat up a little bit and then I apply the solder. I find that works for me. Different people have different methods. That's certainly what works for me. It's getting quite hot quite quickly. Surprise, surprise, copper conducts the heat. Makes it a bit more fun. There's not as much solder on there as I'd like. That's better. Cool. Positive, red, positive, positive to the center pin. Always like double checking. Yes, I do not have a fuse on this. Whole reason is these batteries have got really good built-in protection. If this shorts, anything goes wrong, this battery will shut down. They do that on the tools already. There's pretty good BMS on these things. So fuses just add an extra level of complication where the battery will just handle it fine by itself. Yes, I do know that from experience. It has happened to me before, so I'm confident that it will shut off when it needs to. Flux, make sure it's gone all the way through, heated all the way around. This iron's really probably only just strong enough for this this thickness of cable, and heating this is crazy. Like, it's already heated right up along that cable. Doesn't take much at all. Because of that, so I can hold it longer. Get some weight behind it. I'm going to hold it with the pliers. See, same problem after yet. A little bit of solder on there and it'll heat up much quicker this time. That straight on, heats up straight away. So a little bit of solder for a bit of thermal conductivity makes a big difference. That's a little bit squished. I'll leave a heat in it. If this was going to be permanent, it definitely would have heat shrink that, but it's not. It's only temporary until I get my 3D printer going, and I just want to test this out. It's no fun having a new toy you can't play with. Alright, so let's hook this up. I went countersunk instead of a bolt on there because the 3D printing, this is only honeycomb in here, so at least it has enough purchase, but it's flush enough to fit onto the battery. And it just happened the only countersunk at this size I had was brass, so that's what it turned out to be. So let's just tighten this up a bit. And use what we shouldn't be using. That's a pair of pliers to hold a nut. Although small nuts like that, it's quite effective. Alright. So, straightforward. Stands on its own quite well. Once it has the weight of the battery on it, it's be perfect. This is flawed in a lot of reasons, for a bunch of different reasons. Like, for example, this board, you don't want to be putting your iron in and dropping any solder on the board, stuff like that. So, as I said, it's only temporary. So let's take the iron. That's supposed to handle. That's a good firm fitting. Hook it up. Hook it up the right way. Let's see if it doesn't blow up on me. So it's on standby. And tilt it up so you can see it. This thing heats up so fast. I'm sure the good raw current of these lithium batteries helps. Wouldn't dip like a power supply does. These things do hold their volts really well. So there you go, sitting right at 340. That seemed to solder pretty good the other day. And let's see if we can, I'll just clean the tip. Not really as hot as I'd like. Haven't really played with this much yet. That's better. 350 is a lot nicer. Alright. Press and hold, set it at 350. So now every time I shut it down, turn it on, it'll be 350. That seems to flow nicely. Put it back in its holder and done. Cordless. Soldering iron. On the go, use it anywhere. And turn it off. Oh, next time hopefully I'm putting this in a case and making it much more legit. But for now, it's doing the trick.